Jake here, creator of Animagraphs, and today we're going to take a look at everything that went into creating the Hoover Dam video. The video is doing super well. It's probably going to be one of my top performing videos, which is really cool. I tend to think of videos as being added to just a body or a stable of work, because being super nervous about YouTube and checking your statistics all the time is not it's not a way to live. So I try to balance that with, just doing videos about stuff that I'd be interested in and blend those with videos that I know are going to hit hard, just to have a nice stress-free life. And so far it's working. But that said, the Hoover Dam video is doing really well, and that's super pleasing. Always love to see it. So first we'll look at my research, my folders stuffed full of historical images and whatnot, and PDFs and all that. And then I'll take you into my model and just show you things that were interesting with this project, things I had to do differently, and new things, because every project with Animagraphs, something new happens, which is why I'm thankful to get to do this, because there's always something new. It surprises me. I'm like, haven't I done this many times now? But every project there's some new challenge that I really have to think about how to get around that. Interesting problems, right? That is a gift in a way. So, and this project definitely had its share of interesting problems. So let's have a look. The Bureau of Reclamation published final reports, and they were very thorough. So there were like 7 of them. I don't have access to some of them because they had probably sensitive information, stuff about internals in the dam and gates and stuff like that. But we have design and construction, diversion, outlets and spillway structures, concrete manufacture, a real page turner, the penstocks and outlet pipes. And then I found this slideshow from a professor somewhere. Let's see. I don't know. Looks like an online education system. But this thing has a lot of photos that I couldn't find anywhere else. So obviously when I find stuff like this, my eyes light up, because I think I've said it before, but I want the information that I need so badly that like I can get sick to my stomach sometimes if I don't tone it down. Like I just really need to make these projects good. I want them to be awesome. And I just want it to feel like you're getting the best quality information just like streamed at you. I think that would be a really satisfying feeling, like Neo in the Matrix, just like, oh, I know Kung Fu, like, but not scary like that. So, I need these projects to feel that way, and to do that, I have to find the best information, the good stuff. So, this little PDF had a lot of great stuff in it. Let's look through. Yeah, the site, Black Canyon. Look at this crazy dude. Man, back in the day. It's so awesome. The buckets. Here's one thing to get across, that all of Animagraphs doing these projects has taught me this, that 100 years ago or whatever, they were way smarter than I thought. Like way smarter. And I don't mean now dumb, past smarter. There's a lot of that sentiment always, that the younger generation is losing their minds and they'll be lazy, and I'm not saying that. I'm saying that they knew way more. Like you'll see in some of the other documents, the graphs they made look like computer renderings. Like they do 3D drawings of the dam and stuff with like pressure and all this, because they're using these high-tech instruments that measure things at really fine scales. And I guess I just didn't know that. So yeah, they were really smart. Seismic instruments. They used all these surveying things on the rim of the canyon to triangulate where the blocks should be placed. Boulder City, this is something I didn't cover at all because that's more like history documentary type stuff, but they put up a whole city just to build this thing. There's one of those, this is for building the city, but there were so many like tracked vehicles on the site. Look at that. The photo of the cooling tower. People online said they had a hard time finding this, and that's true. It's hard to find. It's hard to find if you just Google it. You won't find good images somehow. Other times in other projects, it's been a lot easier to just Google and find some like quick reference and then dig for more later. But this one was, without PDFs, I wouldn't have found it. Like I assume as I get more into these projects, as time goes on, I'm going to be at libraries looking through books, which kind of I like, actually, finding information that the internet doesn't know about. Oh man, that's awesome. Look at these fellas just dangling off the side, the high scalers. The bosun's chair. You can see here that the bridges that spanned, and like the rubble piles and a little barge down here, and all the little, like I said in the video, looking like an anthill. These are the, looks like upstream lower portals, so that's the downstream portals for the diversion tunnels. But look how much is going on just at this place here. And this is early on. Look up in the corner here. See that? Rubble piles at the edges of the river. So the adits, or some people said adits, I don't know, adits, I'll just say adits. The adits would be up in here somewhere, but you can see they made little shelves to work from with all the rubble. Just so much detail. You could make a whole channel on Hoover Dam, you know. When they made the rubble piles before the coffer dams, like I said in the video, the dump trucks lined up on the suspension bridge to dump stuff down into the river. Here we go. Here's where this little document gets into more machines, the trucks. It's so amazing. They don't have any windows on the cab. They're just chilling out in open air in these hulking trucks. These are chain drive trucks. I hope that some of the enthusiasts would see that I cared about the accuracy enough to model a Mack, an early Mack truck. If I'm going to include a detail, I want to make sure that it has things that will please people that know. It's not good enough to fool a bunch of people online who don't know anything. That's easy. If you can convince the experts who do know, then you've done your job. I love that feeling of having people who know something be delighted to say things like, oh man, he included this detail. Yeah, that feels awesome. The way they're built, because they look like they're kind of getting modern, but it's so close to the inception of motorized vehicles. 20 years, 10, 20 years, and they look like this. Yeah, there's one of those Mack trucks. Some of them have a little bit different design, and they had protection for their heads. That was a new thing. The solid rear tires and the inflated front tires, and then again the chain drive. On both sides there's a chain drive. It's really cool. Look at these old monsters. Wow. The 100-ton electric shovels. Just so many machines that I didn't model. This is for carrying penstocks. There's an old documentary on YouTube that I saw was being recommended with my video, and it really fills in like that anthill feeling. It shows all the people at the canyon sides and all these just stuff going on. So this particular little trailer is made to carry those penstock sections from where they were built to the canyon rim. Yeah, they made a special highway for it. There it is, the penstock section. Really cool. Here we go, hoist houses. Those I showed. And their wheels. All the electric lines, I didn't model those, but to supply power to it. It really surprised me how many hoist houses there are. I have in my images, equipment. Let's look at a few of these actually. Yeah, look at this. So there's Boulder Dam there, what it was called before Hoover Dam. The river going through Hemingway Wash. And here you have, they found like a store of aggregate, like a massive gravel pile. I don't know about this stuff, but I'm sure geologists and whatnot would know. But they found a massive gravel pile in Hemingway Wash that was good to use for aggregates. And then the water storage tank. Where is the, okay, high-level mixing plant, the low-level plant, boat landing? Oh, there it is. Gravel plant, water clarifier. This is it. The map is just big. Okay. and a trail. So cool. Sorry if I repeat myself a lot with so cool and awesome, but I don't know what else to say. I'm just enthusiastic, you know. You'll probably hear me say that a lot. This is something I didn't model, the structure they built. And this was something for the derrick that I described in the video. I realized that I didn't fully describe that. They installed that so they could keep using the low-level mixing plant and not just have to use the high-level plant. So that it would be convenient, so they could take concrete from down low still after making the diversion tunnel. So this shelf here, and there's a little tunnel that goes back to the low-level mixing plant. Yeah, so I think this is what I was originally going to show you, is they have the location of every hoist. There's like people movers and hoists everywhere. Way more than I showed. I showed a few of them, but there's more. One of the things I thought was really cool is that I discovered that they had excavations in the terrain, and there's still marks. There are still imprints from where they had temporary cableways. Right here, look at this. Here's the spillway. There's an imprint from where a cableway was. And I think on the other side, right here, where this tank is. You would never know something like that just visiting. Of course, why would you? But so the other cableways were up in here, in these regions. This map here shows the location of all this equipment. There's just a lot going on. Rail lines, the low-level plant, high-level plant, right here. Yeah. So back to that slideshow. Look at that, the hoist houses. The 150-ton cableway. Yeah. This looks like a different cableway because the 150-ton has that carriage, but some of the historical photos of people just chilling up in the air. Oh wow, so they were advanced, but this is wild, just standing on there like no big deal. More penstock lifting. It boggles my mind the scale of things. Like they made a special hoist just for the penstock sections that connects to this contraption, the 150-ton cableway. Just how much work would go into designing this one piece? There's a whole train car going down, and they would set them down on this landing here on the platform for the power station, and they still do that today. Look at this thing. Wow. Here we go, getting into the drilling jumbos. There's the heading. And the drilling jumbo down here, starting things out. There we go. The higher shelf there. And the drilling jumbo down here. This is the guys crouched on a lower level. Look at this, way down in there, getting the lower level from that drilling rig. The barge is on the river to drill the initial adits. Air compressor. Again, I didn't model that, but there's the air compressor and the water they'd be using. More air compressors. And there's an adit opening right there and a little temporary suspension bridge. This would be right down at the face of the dam, as I showed in the video. There's the inside of the adit. They always have like supply lines for air, ventilation, lighting, electricity, and rail to cart out rubble. But we were really experienced in mining. Mining is ancient, so these guys knew what they were doing, you know. Here's an interesting thing. The drill steel down here, they had shops set up that worked 24/7 to sharpen drill steel. Just thousands of pounds of drilling steel, keeping that sharp, keeping it operational. Didn't show this one, but this little arch, you can't see it in this photo, but there's an arch behind here. That's from removing the invert section, the construction road in the tunnel. And this jumbo here is just for trimming the walls to make them round. So they would stand up there and jackhammer and whatnot. The invert forms. Here's the sidewall jumbo that I did show for pouring concrete. And the arch jumbo for the roof of the tunnels. I showed that. Look at that. This I did not show. The pressure grouting jumbo, but I showed the grouting right in the tunnel, but not the pressure grouting rig. Just as involved as the other rigs. There you go, the pressure grouting rig again. And they made the penstocks and all the other tunnels in similar ways. They're just as involved. Look at all this gear and equipment and all the people in here. So much detail. But yeah, they followed a similar process. So everything looks like that. Just insane. Like you can't even imagine everything that's happening in that moment. Look at this. This is on a tilt. That's why it's curved right here. These go down into the tunnels. So those are at a slant. That whole track and everything running on it is going at like a 45-degree angle or whatever. Amazing. Diversion tunnel openings. There's the photo inspiration, the 100-ton shovel and the truck. They could barely fit it in the tunnel, so they had to really think about that. And trucks going by each other was a problem. So it was a tight fit for all this equipment in the tunnels. Some diamond drilling rigs. There again, inside of the dam somewhere, I think. Yeah. The drill cores, I showed that in the video. They were really meticulous about these. Where they pulled them from, all that logged and dated. There you go, more drill cores. Here's the drill bits, plug bits, and core bits. These are before they have Bort diamonds inset into them. So there's the fellas working. They stand in trays. There's another photo of this, but they stand in trays so they don't lose any diamonds, so they can pick them up if they drop them. Because even though they're non-gem quality, they're still expensive. So this is the fella setting diamonds into the bit. Look at that. It's kind of hard to find a close-up photo of the bits, but I eventually did. This is pressure grouting stuff. There were different locations they pressure grouted the dam from, so this one's up on the rim by one of them tilting towers. The one I showed in the gallery. Here's one in one of the abutment galleries. Pressure grouting rig in that one of those huge slanted staircases in the galleries. Look at that. Here's a picture from the 1983 flood, the only other time besides, like, I think in the 30s or 40s that the spillways were used. Look at it go. Man, that's amazing. And this is interesting. When that happened, the one that happened in 1942, it looks like, this is a picture from down in the spillway. It carved like 40 or 50 feet. There it is. Yeah. Just from like a measurement was a little bit off in the elbow tunnel. And so the water from cavitation, which is when, I would know if I had done a project on it, but I think water bubbles go supersonic or something, and they end up becoming really destructive. So the spillway tunnel, where it matched with the other forms, was not perfect, and the tiny little imperfection caused cavitation. So it, can't find a good photo of that, but it carved out a huge hole in the bottom of the tunnel. I guess this is the best photo I have. Carved out a massive hole, damaged it badly, so they had to go in, fix that, pressure grout it, and make sure there were no imperfections. You just don't think of it being that space age, you know, but it is. Here's photos of them just dumping from train cars the excavated material somewhere else in the canyon. A lineup of trucks. The preparations between laying lifts of concrete were really technical. They had to wash the concrete and clean it and keep it at certain temperatures and certain moisture levels. This is a tool used to vibrate the concrete to get the air bubbles out. They still use these today. Not this exact model, obviously, but here's the riverbed excavation. Yeah, look at that. Wow. And building the Hoover Dam. This is the upstream Hoover Dam, the concrete face. Here's a catwalk going over the intake towers. There we go. Dumping some rubble in to start diverting the river. I found technical drawings on these gate openings as well, and they're way more involved. I didn't even go over it, but these things are intense, these gates. Up in here, the works, chain drives and hydraulics and all kinds of crazy things going on there. The tunnel plugs. Look at that. They beveled once they found that inner gorge way down in there, in the river bottom, they beveled the edges, smoothed it out. Way down in there, you can see how far down they were. The documentaries show the lines and lines, just day and night traffic of those trucks going out of the canyon hauling dirt out. Dirt and rocks and whatnot. Here's some more images on the cooling and placing. So there's a cooling pipe there. One of the surface keyways, the forms. The cooling tower again, and an image from far away. And that central slot that was later filled. And they also, by the way, grouted all the water pipes. They filled them with grout when they were done. So it's a solid installation. More cooling pipes. The front of the dam as they're working on it. Here's all the cooling installation and platforms and whatnot. Yeah, look at that. There's like lifts that go up and down the dam and scaffolding for different things they're doing. These little brackets here are the foundations for the administration building. I didn't show those foundations, but I think I did build them though. Once they got up high enough on the dam, then they start doing things on the outside instead of the inside. So pressure grouting is the same way. You'd see platforms on the outside, way up high. Yeah, like that. Cooling headers, all sorts of detail. Here are some of the images where I took inspiration for the progress of the dam. As time went on, yeah. Look at this. This is a pretty good picture. You have the derrick here, all those cable lines strung above, and a ton of detail at the dam itself. The power station's coming into formation here. Here's a cableway transporting workers. Wow. Here's a picture of getting close to the top, but you can see the methods are still the same. The forms, high and low blocks, keyways, yeah. The intake towers. Looking through the design and construction PDF, let's see what's in here. Some really excellent layout drawings. From the side as well, I used these to get the cofferdams right. There were other images too that had the exact heights and dimensions and whatnot. Here's an image of the galleries. I didn't realize too that this particular drawing is actually flattened. It's not in the actual arch shape that it would be in. So I was confused when I first put this in my 3D file. It's been like flattened. So I had to kind of guess a little bit where these galleries go. But the side image is useful. So there's all the internal galleries. Well, there's more than this, but this is what I used. This is awesome. So it shows the canyon walls and the altitude lines, and then the abutment excavation. Yeah, this is so neat. And it allowed me to reconstruct the actual cutout at those elevation lines. Look at that, it lines up perfectly. So I load this in and then draw my excavation from there, down the canyon walls. That's what becomes that part in the video. Look at this, grout pumps, if you ever wanted to know. Ooh, look at that. The galleries. Here's a gallery form being wheeled over. I showed that in the video. Look at that. Just one piece of the gallery form takes a whole custom huge truck and trailer to haul over. And the dam has so many of these. This is what I mean. Look at this. Detailed graphs of temperatures. Yeah. Where they're at in the dam and all this. They have so much of this kind of material. It seems like a computer render, right? There's pages and pages of this kind of stuff. The cooling pipes layout. Here are graphs showing how the grout filled those keyways in the blocks. So it shows this at different stages of grouting. Look at that. Here's the grouting pipes into the galleries. I wasn't gonna model that. Look how detailed, just in that one part. Yeah, like detailed graphs of deflection when they grouted, how far the blocks moved. This graph is so cool. This shows how far the blocks moved when they grouted it at different points in the dam. Isn't that neat? It just looks like a computer render. The diversion and outlet tunnels, the bulletin number 3. Look at this. Here's the drilling schedule. So this is where I got the information for how they drilled the headings, the wings, the benches, and the invert section. This is showing the different jumbos. Here we go. Here's an image of a blueprint showing how those huge gates work at the tunnels. Hauling the pieces over. It's so big. They had a trash rack on that Nevada tunnel number 1 that was used, the final tunnel that was closed. They had a trash rack on it because of those sensitive gates and whatnot in the tunnel plug that I showed in the video. So that's interesting, right? That they were using that last tunnel in a different way than the other 3. Here we go. So there's the internal gates for controlling the water flow inside of the tunnel plug. And the elbow transition where, like I said, this had to be mathematically perfect, and when it wasn't, that flood ruined this part right down here of the tunnel. So that's how, it's just amazing that something that big would have to be so precise. Here's the intake towers, all the dimensions and pipes and gates from above. The gearboxes and the hoist mechanism for putting the gates in place. And then a detailed image of the penstocks that feed the power stations from the intake towers, all the elevations and Latin long coordinates, angles, you know, what kind of materials there, what kind of rock. Of the penstocks, the ones that are in the diversion tunnel versus the ones they excavated a separate tunnel for. So here's all the angles and measurements and placement for those. The placement of those penstocks inside of the larger tunnel. The valve house setup. All of these pipes had intense flow calculations made and studies. They set them up in a laboratory and they built like what looks like plexiglass and acrylic models of this stuff. Here's an image, a side view of the needle. They actually, these needle valves that were replaced, they used the water pressure of the water going through it to actuate the valve. I mean, I kind of wanted to go into it, but the video is already super long, but they used the water like in these internal passageways in the needle valve. They used water pressure going through these passageways to move the valve itself, which I thought was really clever. Here's the tunnel outlet works. They also studied these pipe transitions, all the branches, and welded them on site. And then the spillways and all the transitions there. Again, measurements, slope angles, coordinates. Yeah, so here you go. This is one of the tests they set up in their little laboratory with all the markings for the spillways, the shape of the channel and the basin itself. Everything has been thought about, everything designed specifically to handle the requirements for the project. But when you're standing there, if you don't know this stuff, and I don't, since I'm not an engineer, you don't know that. You don't think that every single inch of those spillways has been thought about and pre-planned. You just don't think that. It's amazing to learn. Here we go. Here's the drum chamber, a gallery, drainage. Here's the chamber for the inlets and the trash rack at the front of the spillway where the water comes in to fill that drum chamber. So here's where I got all that info. The piers. There's so much cool stuff going on in here too. So many little passageways and places where people can go in there to service it. Everything on this dam is so huge. Right, so those are all some of the PDFs. I mean, I've got more. I've got more. Let's just have a look in my assets folder here. High scaler, that's what I was looking for there. The coiled up rope. I wanted to get some of these knots pretty close or even correct if I could. I do get into that kind of detail with my ships. I'll make sure the knots are correct because Again, I just like surprising people to know that I would care about that level of detail. The level of detail I aspire to in these projects does come from it's not necessarily a compulsion or like a drive to perfectionism. I think a lot of artists, especially in the past, you can see where like talented people, artists who had drive also had some pretty deep demons and gremlins and things in there. So I just think it's important inside of me to understand where all this drive comes from, because I don't really like the way that modern capitalism talks about drive and how you should be grinding and all this. I don't think that's true. This comes from an appreciation for details, and my intent matters, I think, and why I want to do this. So stuff like this is so important, where I have the whole plan, even though I'll need more, but just to set up my file. So if I go into my 3D file here, let's see, my references. In the 3D file I have all of these folders and collections, they're called in Blender, to organize just my reference. So this is my file down here, all these, right? But the reference folder inside Blender is huge as well. So if I turn this on and turn off that terrain model, there it is. That's the image you just saw. It looks like I have something else loaded up. Yeah, it's the side profile of the dam and the top. All of the elevations and the shape of the dam at those elevations so I could rebuild it. To track these elevations in Blender, I built an altitude ruler so that no matter if I built an object. So no matter if I could see or not these images, depending on what mode I'm in Blender, I can still see the altitude in divisions of 5, it looks like. From the base of the canyon at 500 or so, up to the crest of the dam and above for other things. So I built that into here. I believe I put the lat and long lines from that map into Blender. One of the things that I really struggle with, that's difficult, is that these images might have been photographed with like a curved lens. Depending on the camera used to snap this, it might not be a scan, and even scanners can do this, but they'll be curved. The images are kind of curved. You might not think it's a big deal, but when you're talking about thousands of feet, and this is an aerial view, when I get down into something like just this elevator shaft in here, you better believe that's a big deal. Just a minor curvature in the camera lens used to take this image can mean that that is no longer in the right place. So lining up images, I still end up having to kind of eyeball it. And the more I build things, the more I know where things are. I can't do it from just one image, even if it looks detailed, which this one really is. It's a nice image. Here's the terrain map. This is so neat. This is how I rebuilt the canyon. I actually had accurate renderings of the terrain, topographical lines. Yeah, I went point by point and drew those lines as they go back to make sure I was getting it right. Check this out though. Let me fly through these images in Blender. So look at this. It actually has the rubble in the bottom as well. See that? The level of excavation from the stones up to the mud. Isn't that neat? That blew my mind when I found this. So if I fly through it, that is how I remapped the actual canyon walls. You can go up here, and as you go up, you can see at different points, it's not, it's every 100 or a couple hundred or 1,000 feet, but this is so neat. I couldn't believe it when I found this. Yeah, the different levels of sediment they found. And there's the last one, but that is so cool. You don't always find stuff like that, so very thorough. And then so those are lined up, and they're also tilted with how the image was taken, how it was recorded. So there's the dam right there. So that's how I recreated the canyon walls. So there's my model in Blender. One of the things that I really used that was sort of a new thing for me in this particular model is geometry nodes. So it's a way of programmatically creating things instead of just doing it by hand. Obviously, like the dam, for example, here, I created that by hand using those reference images, and then I'll look at the top and the side and the front and make sure all the points are lining up, and then I model that up. I'll go to my timeline. This is what I'm usually looking at when I'm animating, is this timeline, because it's got the camera keyframes and my voice down here. I have these sliders I set up over here so that my file becomes interactive, so that I can use this, so it's easier to use it when I switch to the animation part where I'm flying around the camera and all that. Anyway, this is set up based on the actual elevation. So at 556 feet, this is what you would see on the canyon floor. And as it grows, they kind of pop up 5 feet at a time. So some of these blocks need to be higher than the others. That was really important because it's accurately how they did it. They had to use less forms that way, so they didn't need forms on the front and back of a block that is low, for example. Right. So these stay in high and low throughout the project, but I also wanted to have that building animation be kind of random of how they're placed. So that's an interesting requirement. As I go up, you can see that working. So what this is this is an actual diagram from those reference images. They have all of these blocks numbered and in their lettered columns. So isn't that neat, like how that's planned out? But I built this object in Blender based on that diagram, and then I have this folder of blanks, so I'll build really simple versions of the shapes I need because I'll use them a lot in the project. I use this blank as a way to cut out these blocks because this is what they look like, right? It's just the diagram, and then I use that other little 3D object to cut these things, cut the one out of the other. It's called a Boolean in Blender. So as I roll up the timeline, you can see that it builds into that shape. And in geometry nodes, this gets pretty wild. This tree got pretty wild because of all the requirements I had, but it's just doing that. It's doing the cutting operation, and it's telling it to build one block at a time, but keep this row of blocks higher than the other and alternate like a checkerboard those blocks. So there's a lot going on in that model. You might not know you wouldn't know that that's happening just from watching the video, but geometry nodes is how I crafted that. So it's all done programmatically, which is really cool. This is a new thing they added to Blender. If I didn't have this, I'd have to do it by hand, maybe shift these by hand and grow them, and it'd be a pretty intense animation. So geometry nodes. I also used geometry nodes to make all the Booleans. I actually have the untouched terrain, so this is just built from when the raw canyon images. But to make all the cutouts for everything, and I'll show you, like I actually have some pretty intense controls for this. So the half cut, yeah, so I can cut it in half here. And then all the cutouts. Look at this. This would be a thing that was hard to do before, to make all these Booleans, but I used geometry nodes to cut these out and to make them scalable and all that. So yeah. This first shot, I just want this to feel huge. Because of foreshortening, you will never see this view of the dam in your life unless you're in a helicopter, right? But when you're looking down or up at something, you can't tell how big it is. When you're standing on top of Hoover Dam, and I have done that, it's awesome. But you look down and you see the top of the powerhouse here. Show you what I'm talking about. When you're standing up here, you look down and you're not really going to be able to tell what you're looking at. It looks just like that. It looks far. You're like, oh, look, everything down there is small, you know? But it just doesn't, you can't tell. So with that first shot, right? Like, I want you to be able to understand how big this thing is, because you'll never see that otherwise, right? All the way up. And so that was my goal with all these things, and that's why I put those little models. You can see the fellow way down in there. I tried not to make it too annoying, because I think if you repeat something too much, then it just feels like you're trying too hard. So I put them as much as I could, but hopefully not too much. But the human model, everywhere that I could put one. The spillways are such a point of focus because the way that the dam is built, it lets you see the spillway. So everyone is really wigged out by these tunnels, and so I wanted to make sure that you can see the tunnels and how big you'd be and how far up it goes. That's a 600-foot drop, as I explained in the video. One of the things that I'm always trying to do, and I think it's working based on feedback in the comments and how people feel about the video, but one of the things I'm always trying to do is ask, why should I care about this? Why should I care about this? I think that one of the things that has hurt modern learning, maybe schools and just personal learning, is being forced to take in and memorize information that I don't care about. You'd be surprised what you can slog through and what you can get through if you have a reason to care. So in my videos, I can never show you something unless I give you a reason to care about it. But I don't think that's a problem. I think that's how it should be. I mean, that's just human nature. It's a good thing. So every time I'm showing you something, that's why, like, when you get down to this part in the canyon right here, where you see that initial block placed, it's because I want you to know why I'm about to show you all this equipment. Because I've been going through equipment and going through the abutments and the high scalars, but before I overload you with too much equipment, there's a balance here. I have to show you why you should care about it. So I show that block down there, and then we go back to talking about all the equipment and the lines and whatnot. And I think that that is a way to hold interest, but for a good reason. Like with what they call the attention economy, you know, and trying to snag people's interest and hold it there. Instead, what I see is people clicking on the video saying, I did not plan to watch an hour of this, or I thought only 30 minutes had passed. But I like that in this case, because I'm not tricking people into feeling bad after you spend a bunch of time doom scrolling shorts and you have that terrible feeling like you wasted your time. Instead, they come away with a bunch of new questions and new interest and curiosity. So something about the way I'm doing that, I think, is really, it's working how I want it to. It's holding the attention, but for a good reason, for a good cause. If you order things properly, the flow of the video will always answer that question. This is why you should care. And people are like, heck yeah, like, I was just going to ask that. I see that a lot in the comments too. They're like, I was just going to ask how that was done, and then you answered it. I feel like I want to get in the viewer's head that way, in my own head. And when I was researching this, the cadence of my own questions to answer them that way. Another way to generate that feeling of awe, you know, I love giving that to people, making your heart beat a little bit, or making your eyes pop open. You're like, how is that possible? The aggregate plant, zoom into there we go, boom. Yeah, just showing, like, actually mapping out the desert floor, because I could find geographical mapping data on the height of these things. You can see the the image, like the shoreline of the lake is still kind of ghosted in there. You know, it's not perfect, but I photoshopped in this sand because this is actually a modern image, but I didn't want that to show through, like all the roads and the human activity. I wanted it to feel historical, so I just kind of made it sandy like I saw in historic photos with no trails or roads. But anyway, this aggregate plant down in here, like showing this, and then bringing in the Lake Mead water object and having it so that you can, whoa, so that you know what it would be like if you were underwater there. Yeah, you can't resist doing stuff like that as a director. Have to. So cool. There's a thing called thalassophobia, of people that are afraid of being great distances underwater. Or like there's photos of people touching propellers on big boats, like divers, but you can tell they're way down underwater. And even that, it gives me the willies too, but like some people have a very real phobia of this stuff. So I wanted to keep it real here, but I also wanted to, you know, do that a little bit because it's such a cool feeling. It generates a lot of interest for me and I think for viewers. I have another video on my tool set, and it is a little bit, I noticed that people who aren't 3D professionals will stumble on that video and get a little lost, and I expected that. But I do go over the tools that I've built, and so not to get into the weeds here, but this render process, this project, check this out. It is 118,535 frames in total. That's a lot of images. And here they are. If I click into these, as I've shown you before in the behind the scenes videos, and just start arrow key through, see the number go up here. I mean, one frame at a time. You just never think it is, but it is this way. This is how it be. These are all the frames. But this was the smoothest render process I've ever had. That frame skipped render where I'll render like every 1,000 frames, but then render 3 in a row. So 1, 2, 3, 1,000, 1, 2, and 3, 2,000, 2, 2, 1, 2, and 3. That saved me so much problems. And you can see that tool in my other 3D tools video, but it made the render process so smooth. I'd render all night, and when I looked at the actual files, you know, in the morning, there wouldn't be any errors. I actually managed to make a way to catch all the errors. And also this render checks, I revamped this. Let's see. Yeah, the system console. This is, I wrote this function to spit out these errors of things that have ruined render jobs. So I made Blender, a function in Blender to check for that stuff. But this time I color coded it. This is what this project I had color coding. And you'd be surprised, just having it color coded, just that, so it's not all just the white text, made it so much easier and less stressful, because when I'm rendering, I have lots of windows open. Again, I go over it in that tools video, but I have lots of windows open, lots of things are happening. It can be stressful to render thousands of frames without any errors. But just this, just having it color coded, and I can quickly see, oh, I got a hidden object. That shouldn't be hidden. Invalid drivers where I'm fading things in and out, like I need to check that object. That's another thing. So, but I just wanted to say, like, this, the render job for this project, longest video I've made yet, and the smoothest render job. So great. Coding, learning how to code, this, my panel over here, all my tools, this custom stuff that I put into Blender, has been really satisfying. And I want to reiterate that this happened one step at a time, like learning to walk. The first thing I coded was not good at all. But then you just build up over 2 or 3 years now I've been doing this. You can build up the complexity to where now my tools are really helping me in significant ways, to where then I can make these really long videos. So yeah, the render process was a dream. Love that. Anyways, I know there's bound to be some gaps in this video. Maybe I didn't cover something that you would like to know or see. They're kind of hard to make. I'm not complaining, but I struggle sometimes to think of what to say because there's so much to cover, and I kind of lose my words, or they'll be a little bit frenetic, the videos. My lamp just changed color on me. Whatever. I guess we'll have yellow lighting now. But I do want to try my best to bring you in and show you just whatever I can remember that was interesting from the project, and especially the research photos and just how I make these. Oh, someone else had a question about, someone said that it was my ego-driven, the intro to the video, but I think there's a lot of anxiety right now about AI, understandably, and I'll use AI as it becomes available to me. If it's useful, I'll use it. I mean, you know, the world is a wild and dangerous place, and when new technology comes, you know, you kind of have to get on board or get left behind. I don't want to get too much into that, but I just don't mind. It's whatever, let's go then. That's how it's going to be. So I don't use AI yet for a lot of things. These projects are, for the next while, still going to be made by hand. They'll be made by me. The voiceover is done by me, and the music is done by me, and the modeling and all that. So I didn't say that in the beginning of the video to toot my horn. I don't need that. I'm just trying to show people that this was made by hand. I think people would like to know. I mean, I don't mind bragging. It's not like I feel like I'm a bad person because I brag a little bit. I just thought it was funny that that commenter, as usual on YouTube, there's people just kind of misunderstand. So anyway, that's a little look behind the scenes of how I made the Hoover Dam project, and I'm just glad that I could share that with you.